सो
ओके
एससीपी इंस्टॉल कैसे करना है मैक के अंदर, वो मुझे भी नहीं पता है, वो देखना पड़ेगा यम से या किससे करना है। इंस्टॉल एससीपी।
फाइलज़िला यूज कर लो, शायद वो भी चल जाएगा। फाइलज़िला।
फाइलजिला, हाँ शायद मैक में चल जाएगा।
फाइलज़िला में एससीपी का शायद होता है
या
ऑप्शन
बाय
मेरे
डिफॉल्ट
ख्याल
एससीपी होना चाहिए यार तुम्हारे पास, वैसे भी बाय डिफॉल्ट एससीपी होना चाहिए। एक बार देखना दोबारा से एससीपी, जस्ट ट्राई डॉट एससीपी विद योर रूट यूजर, क्योंकि एससीपी तो होगा ही होगा, बाय डिफॉल्ट ही होता है एससीपी तो, मतलब उसमें इंस्टॉल क्यों करना पड़ रहा है मुझे भी समझ में नहीं आया। एक बार ट्राई करके देख लो, वरना फिर क्लास के बाद अपन देख लेंगे, नॉट अ
है।
प्रॉब्लम। Okay, so that poem will basically resolve both of your issues. Just put it on. Can you put it on? Okay, fine. Now, can you put it on mute? I think some of you have logged in from two different devices.
या जो ये है फॉर्म, इज इट पॉसिबल फॉर यू टू जस्ट मेल दैट फॉर्म, बिकॉज वो जिप होगा ना पूरा, फिर
नहीं जस्ट
पूरा
फाइल को,
जिप दोबारा से
जस्ट
लेना।
नहीं नहीं जस्ट फाइल को डाउनलोड कर लेना वहाँ पे जाके।
अच्छा ठीक है समझ।
Okay, so I'm sharing my screen. Okay,
एक्चुअली वो फॉर्म फिर भी नहीं चला।
नहीं चला?
हम्म, हम्म, उसमें
क्या
एक और है।
क्या रहा है?
मैं बता रहा हूँ कौन सा थे। फॉलोइंग ITHM जार। एक मिनट मैं भेजूँ उसमें टेक्स्ट।
नहीं 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 यार, ये तो चलेगी, मैंने
टेक्स्ट।
कल पूरी चलाई है। मैंने अपनी M2 को डिसेबल करके, वो मैंने पूरी डिलीट करके फिर चलाई है, तो ये चल रही थी, पूरी तो बन गई थी। आई मेड यू द प्रेजेंटर।
मैंने अच्छा। ओके शो माय स्क्रीन।
ये तो मैंने कल बैठ के चलाई थी, भेजने से पहले मैंने एक बार चला लूँ, फिर से कोई एरर ना आए।
Failed to execute goal on project map reduce, could not resolve dependency for the
फेल्ड
project
एग्जीक्यूट
this। ये
एड्रेस। एक सेकेंड, फॉर्म दिखाना दोबारा से।
एक मिनट फॉर्म देख सकते हैं। ओल्ड फॉर्म मैं नया वाला दिखाता हूँ तुम्हें।
हाँ, दिस इज द करेक्ट वन, यस। यू हैव नॉट मेड एनी चेंजेस
नो जस्ट अभी
एंड
तो मैं बेसिकली आई जस्ट imported it। डॉक्यूमेंट्स शेखर पिक डेटा सोर्स कोड मैप reduce।
ठीक है।
ठीक है।
हाँ
यहाँ पे यहाँ पे
ठीक है।
यहाँ पे मेरा फॉर्म है।
ठीक है, अब गो टू योर टर्मिनल, गो टू योर टर्मिनल।
पहले मैं वो दिखा देता हूँ मैं कहाँ पे हूँ। शेखर डॉक्यूमेंट्स बिग डेटा सोर्स में इस प्रोजेक्ट पे हूँ। ठीक है।
ठीक है, गो टू योर टर्मिनल।
Maven install। You can see
एक सेकेंड,
I'll go slow so that you can see।
I can see you. You can just maximize it. Yeah, just do ls.
maximize or
हाँ
minimize।
ठीक है, बस just do ls।
एंटर करो पहले।
ls पहले ls करो।
नॉट फाउंड। यहाँ पे है। ये तो चल रहा है।
जस्ट ls कर दो यार, जस्ट ls ही कर दो केवल, कोई बात नहीं।
अरे से भी नहीं चल रहा।
तो मैं क्या, कुछ गड़बड़ है यार, ls क्यों नहीं चलेगा? वो इसलिए scp में चल रही तुम्हारे, कुछ गड़बड़ है इसके अंदर, आई डोंट नो।
हाँ इसको
ls
मुझे देखना पड़ेगा मुझे।
ls क्यों नहीं
एलएस में
चलेगा?
एलएस
ls तो
में
चल,
चल रहा था। होल्ड करो एक मिनट। PWD चल रहा है यार। हैंग ऑन 1 सेकंड लेट मी फिक्स इट। ओके बैश लिख के एंटर मार के दे दो।
I think yeah, you're not on Bash probably. Bash.
Shell.
Bash.
Hang on 1 second. I'm very
मेरा चल रहा है पॉम, मतलब मैंने अभी mvn clean इंस्टॉल मारा है तो डाउनलोड कर रहा है वो।
कर रहा है ना, हाँ वो चलेगा। वो मैंने कल रात को मैंने पूरा चलाया था, मेरे डॉट एम टू फोल्डर मैंने डिलीट करके फिर उसको चलाया था मैंने, इसलिए।
हाँ वहीं पे डालता है ना सब कुछ।
ठीक है, मैं इसको चलाता हूँ। ठीक है,
हाँ ठीक
मतलब
है,
मैं देखता हूँ
ये
दोबारा
चल रहा
टर्मिनल
है।
शुरू करके।
हाँ इसके भी
हम्म,
चल रहा है क्योंकि प्रभुजीत इज ऑल्सो एबल टू रन इट अप, सो देयर शुड नॉट बी एनी
ठीक
प्रॉब्लम।
है।
ठीक है, ओके।
हाँ, अभी चल रहा है। ठीक है।
कुछ गड़बड़ है फिर, उसको देखो जरा। प्रवीत अगर तुम्हारे को एरर है तो बता देना। आई एम अगेन टेकिंग बैक द कंट्रोल।
एक मिनट, हैंग ऑन 1 second. Okay, now I got it. You took the control?
Yes. Okay, I'll give it to you again.
Oh, ऐसा है क्या? तो अभी मेवन क्लीन इंस्टॉल नहीं चल रहा क्योंकि इसको फिर से मेवन सेट करना पड़ेगा। ठीक है,
अरे
इसको ना मैं
वो you have to
सही।
you just put it in your dot bash प्रोफाइल। एक आपके उसके होम के ऊपर एक डॉट bash प्रोफाइल फाइल होगी, उसके अंदर डाल देना मेवन का पाथ, तो हर बार वो बाय डिफॉल्ट ले लेगा।
हाँ,
डॉट bash प्रोफाइल
मैं
नाम
वही
की
कर।
फाइल। ठीक है,
हाँ,
ओके।
ठीक है।
सो जस्ट ट्राई इट आउट, ये चलेगा। प्रभजीत के भी चल रहा है, मैंने भी चलाया था, कल चलेगी ये फॉर्म, इसमें कोई प्रॉब्लम नहीं आनी
ठीक है।
चाहिए। ओके ओके। सो Apache Hadoop compression. So I hope you remember we talked about some little bit about compression in the last class, last to last class indeed. So we talked about different benefits of compressing the files at different stages. So if you can quickly recall at what are the three stages where we can compress up and what are the benefits of compressing the files. Can you? Anyone?
I don't remember.
Okay.
Like in general, compression can save us a lot of time and not processing, but I guess time and bandwidth. Apart from that, no sure.
Yes. Yes. So basically, compression reduces your IOs, and that inherently reduces your processing time. So so higher the compression you have, least the IO you have to read the file or write the file. So you can apply the compression at reading at the mapper phase. You can apply the compression at emitting the data from the mapper phase. You can apply the compression at the emitting data from the reducer phase. So all the three phases, mapper का input, mapper का output, reducer का output, at all the three phases you can apply compression, that we talked about in the last class. So as I told you, compression gives you a pretty good benefit and it reduces the IO, but however you have to decompress the files. So decompression will increase your CPU uses. So you have to precisely choose which compression you want to use up, and you have to also check your cluster based on the cluster performance and different parameters, how much your CPU is free and how much you are wasting on IO, how much processing time you are doing up, and based on that you have to precisely choose the compression technology for your jobs. So basically CPU बढ़ जाएगा, compression बढ़ा, compress higher you compress, the lower you compress, your CPU must be freer, but your IOs will increase. So that you have to precisely choose the correct compression technology to process your data faster up. So those things will come with experience only. But once you understand the concept, you will get to know where to think, how to think, and then which compression to use up, which not to use up, based on your job, based on different criteria in your organization. Those will come up with experience only. but you need to understand the basic concepts, which are the different compressions available, which need to be used at which phase, which is the best one for me. So if you understand those things, you will be easily able to apply or think of which compression is suitable for your jobs in your organization. So compressing output files. So to set compression or to enable compression, as we have seen that that day also, you have to just set compress output and compression codec. These are two things which you have to do up, and rest all thing would be done to you. So these are two lines which you have to write up in your job configuration class, and the rest everything will be taken care by your whole framework. So you have to just tell कि कौन से phase पे compression लगाना है and which compression codec you have to use. So here we are using zip codec. So this will create these are the files. Okay. So compressing the mapper output, for that you have to just set so for that you have to just set mapper.compress.output. So this will compress the data emitted out of the mapper and going to the reducer, not the data emitted out of the reducer. So you can compress the data which is emitted out of the mapper also, and there also you can apply different compression technologies. So, and you can apply compression at different levels, like you can apply compression on the record level or on the block level also, or on the file level. So you can apply compression at different levels also, black level, record level, and those kind of things. This is again, you can configure up something like this. The most interesting thing. These are the four different compressions which are available by default in Hadoop world: ZZip, BZZip, LZO, and Snappy. Slowly and slowly you will remember the names. But let me give you a intro about all of them. Oh, sorry. Sorry. Uh, so basically ZZip and BZZip above the red line, or red line थोड़ी सी टेढ़ी मेढ़ी हो गई. ZZip and BZZip2 give you pretty good compression. That is, they compress your files at a very high level. On text files, you can achieve compression at of more than 80% in different scenarios. For logs kind of thing, you achieve 80 to 90% kind of compression with the help of ZZip and BZZip2. However, LZ and Snappy give you less compression, 20, 30, 40% kind of compression on your files. So that means the compressed output files of LZ and Snappy are basically more in size as compared to ZZip and BZZip. However, on the however on the other side, LZ and Snappy use a less CPU because they compress less. So these technologies on the decompression on the decompression phase requires or less CPU cycle. But the most interesting part of all these things is splittable. There are few compressed file formats which are splittable while few others are not splittable. So now my question to you is, and I want to answer from both of you. So this is my HDFS. I am reading the data on the mapper phase from the HDFS. Mapper is emitting the data to the reducer. Reducer is again emitting the data back to HDFS. Okay. What do you think at which phase I should be applying which compression format? I gave you a little bit basics about all the compression. This is all what you should be knowing up also to apply in your production environment. Uh, what is the algorithm of these things, you don't have to worry about because no one looks at this thing. I also never looked on those things. You have to just know about which compression gives you what kind of compression, and whether they're splittable or not. And that's the only thing which you have to require know about these compression. So based on this, can you
Uh,
think of? at which phase I should be applying which kind of compression. So this is your phase one.
Miraj, I think
Yeah, go ahead.
Phase 1 LZO or snappy. Phase 2 should be GZIP or BZIP.
Okay. And phase three, emitting out of
No,
the
no,
vehicle.
sorry. Yeah, so phase, okay, you said phase 1 is ZZIP,
Okay, that is not a
phase
splittable.
2 should, sorry?
Z-zip is not a splittable.
phase 2 should be splittable,
Phase two should be splittable.
and one can be like non-splittable, and even
SDFS से
phase
डेटा
3.
कौन पढ़ता है?
No, sorry, one should be splittable, and two should also be splittable, and third should be
Why
non-splittable.
why two should be splittable?
Because data from map to reduce
Mm,
can pick the data, in chunks and then apply the logic.
Yeah, but what is splittable? What is split? What is a block and what is a split?
yes,
You remember what is a block? What is a split? Right? I
yes.
explained you. So now again
The
think of
split may spread over the block, right?
yes. So now again think of which layer, which compression do you think is best?
Okay. So, so for one, I think BZIP2 should be applied because you need more, it has to be splittable.
Yeah.
So for phase 2, now map to reduce, neither has to be splitting, but it has to be less CPU intensive. So I think LGO should be applied.
Sorry?
LZO, the
Okay.
third one.
Okay.
I'm just thinking, can you have Snappy too?
Okay.
And then R, you don't really need anything. So you could apply, on third you can apply gzip.
On third, but the data is lying in SDFS, another mapper would be reading up or you would be processing the data again. So basically map reduce का phase यही होता है, आप डेटा को प्रोसेस करते हो SDFS में डालते हो, फिर कोई दूसरा मैपर उसको प्रोसेस करता है, कुछ और का चलता है, एट द एंड में एक छोटी सी टेबल आ जाती है, छोटा सा डेटा सेट आ जाता है जिसके ऊपर आप चार्ट बना के यूजर्स को दिखा देते हो. In the industry this is what happens, right?
Yeah.
So
So 3 could be, I think, again bzip2.
okay.
No?
नहीं, I'm just
According to
yeah
me.
yeah
So
yeah sure sure. Basically ऐसा कुछ particular criteria नहीं, but I'm giving this exercise so that you recall everything what we discussed, and you should thinking aloud. And so at each phase you can apply any kind of compression, but yeah, I was just wanted to think what is the logic you want to apply. Yeah, I totally agree with your point. Prabjeet, totally agree with your Shigar.
Mhm.
Prabjeet,
One should be like splittable, LZO. Phase 2 should also be. But actually, I'm not able to recall that splittable and relationship between split and
so
uh,
split is anything which is splittable. So the data Can you put yourself on mute for a sec? So you remember अगर डेटा दो ब्लॉक्स के ऊपर मेरा लॉजिकल डिवीजन हो रहा है तो then I have to create an split and the data from another block transferred to the block where the mapper is running up and that mapper processes the whole data. So that is a split. So if the file is not splittable, that is the reader which reads the data for your mapper. If you remember the input text input file formats and other file formats, and the record readers which read the data, they will not be able to figure out where the logical end of your data. So they will not be able to create the splits for you. And if they are not able to create the splits for you, your 15 TB file or 10 TB file or whole file will be read by a single mapper because you can't create a split on your data. So all whole file will be considered a logical block, and all of your data, चाहे 15 TB का हो, चाहे 100 TB का हो, चाहे 1 petabyte का हो, will be processed by our single mapper.
Okay. And also में जो difference लिखा है like yes if indexed. So this index is based on the data, right? Like if data is indexed, then only we can use also.
If data is indexed, so don't worry about वो कैसे करते हैं, वो केवल एक पैरामीटर पास करना होता है कमांड से, वो सब कर लेता है अपने आप. So you don't have to worry about those things. Hmm. Okay, so Shekhar, yes, you were right. We should be applying BZZip or ZZZip kind of thing. Anything on the SDFS. And LZ and Snappy will make more sense onto your mapper, the data which is transferring from mapper to reducer phase, because there we have to basically process the data on the same go kind of thing. So that is what normally is this industry standard. But again, it's all your wish. You can store your whole data into SDFS and LZO, or you can store your whole data in BZZip or LZO or Snappy, anything in your SDFS. But this is an industry standard. What people normally follow is LZO and Snappy at the phase 2 and GZIP or BZZip2 at the phase 1 and phase 3. Now, as BZZip2 file is splittable, so that is more preferred. Again, ZZip file can be very splittable with the virtue of different file types. So I will not talk about the file formats. So with the virtue of different file formats, we can achieve the splittable files with the help of ZZip compression also. So that I'll explain you in few minutes in the next few slides. But yeah, that's a perfectly good understanding of the system. And this is the industry standards also where which compression are applied, which at which layer. So again, based on your data type, based on your different things, you would be choosing the precise compression based on your requirements, based on your CPU available, कितना CPU free है. अगर CPU बहुत ज़्यादा यूज है तो BZZip and ZZip यूज नहीं कर पाओगे क्योंकि CPU bound आपकी एप्लीकेशन है और CPU bound आपका क्लस्टर है. In that case, you would be using this thing only. So again, that will be again based on your based on the production scenario, based on your clusters, but this is the industry standard.
Miraj,
हाँ जी.
gzip, like you told gzip will using gzip we can achieve around 80% of compression, right?
Yes.
But I think so. What about the time of unzipping or zipping? Will
Yeah,
it
but
be more or?
of course, decompression में time तो लगता है ना. CPU bond है ना.
या तो जितना ज्यादा कंप्रेस होगा उतना ज्यादा टाइम भी लगेगा, राइट?
Yes, so
तो
that's what I think.
इसमें
That's what I'm
हमें
saying. So that will
ओके.
depend on your particular condition, but definitely IO का time जो है is more as compared to compression and decompression in most of the scenarios, because you know अगर आपका डेटा जो है वो 1 जीबी का है और आपके मैपर जो कंटेनर्स जिसमें मैपर चल रहे हैं वो 2 जीबी के हैं, तो अननेसेसरी वो अपना सीपीयू वेस्ट ही कर रहे हैं. So in that case, if you compress this and give it a 10 GB data, that will release leave your CPU with more containers, and you will get other users will get more CPU, and that mapper will be doing a task for you. So there are a number of things will comes in picture, but yeah, definitely किसी phase पे आप time save करो तो किसी phase पे yeah definitely you will be wasting out more time.
Okay, sure.
Okay, so zzip is naturally supported by Hadoop. Zzip is general purpose compression and sits on the middle space of trade-off. सब ये मैंने सब बता दिया है. Basically, by default zzip ही होता है. अगर Hadoop में आप compression नहीं दोगे तो by default zzip ही लेगा. bzip, as I told you, is again gives you good compression. It compresses your files up to 10%, 15% kind of thing. So basically gives you 80 to 90% kind of compression kind of thing. And and the files are splittable. That's a major criteria for you to choose bzip2. Elzado gives you a pretty fast compression and decompression because the compression and decompression ratios are pretty less as compared to zip and bzip2. However, the compression the percentage of compressed file as compared to the original file is not that much. You can't achieve, you don't achieve those kind of compressions. And Snappy is from Google basically. So highly used in at different places, but again the Snappy is not splittable. So these are things which you have to take in the mind before choosing the correct compression technology for you in the Hadoop world. To set up compression, it's simple configuration देना, nothing else. You don't have to worry about कि अंदर क्या हो रहा है क्या नहीं हो रहा. It's all pretty simple. So another thing which I was telling you was when you compress your data, so let's say I have one file which was divided into, let's say, 10 blocks, and now that file is compressed, and say I have achieved 50% compression or 80% compression, or let's say this file was 20 blocks. Now I've achieved let's say 80% compression. So this file will now be only stored in 2 blocks. सो 2 ब्लॉक्स में होगी तो मैक्स इस पे 2 ही मैपर चलेंगे, मैपर 1 and मैपर 2. So each mapper is now processing your, rather than it was previously it was just processing your approximately 64 MB data. Now it's processing your 64 MB into 10 640 MB data. So so that the data is basically lying on a single node and the mapper is processing that kind of data. So that might also make your application CPU bound on particular places. So again, you have to think of कौन सा compression किस layer पे लगाना है. Getting my point? What I'm saying?
Yes.
एक बार repeat कर दो please.
Okay, Shekhar will repeat.
So suppose if you have a file which is split on 20 blocks, so if you compress something to 80%, any compression technology, so now the file itself has got smaller, so it will now go to 2 blocks instead of 20 blocks. The data has become that small. Now, if the data is small, worth only 2 blocks, then only instead of, if you didn't unzip the file, the data would have been in 20 blocks, then 20 mappers will run, one for each block. Now the data is into 2 blocks only, then only 2 mappers will basically run because the data is only on 2 mappers. So what you have to do is, based on what you want to know, CPU versus compression optimization, you should use the compression technology which is most optimized, either LZO or bzip2 whatever is required, because you have to come up with a performance overall on mapper and CPU processing. So does it make sense?
Yeah, yeah.
So we have not looked into
But
the.
Did I miss anything?
No, that's perfectly fine.
I just have a question in that, small question, not related to this, but when I was reviewing this question came to my mind. So suppose if your block size is 64 MB,
Mm-hmm.
okay, and you have a 70 MB data. So you will go into two blocks. One is 64 MB and another one is for 6 MB will go into another block.
Mm-hmm.
Now, it is possibility that this 6 MB gets into another rack, right?
Yeah, definitely.
So now your splitter will be only one because the data is uh, basically the line example which you gave, right? You know, you broke the line in between. So is it a possibility that splitter can read data, has to read the data, reader has to read the data across two blocks into two different tracks?
सी अगेन उसकी कुछ मतलब ब्लॉक एक है तो उसके ब्लॉक के 3 कॉपीज होंगे तो हो सकता है उस रैक में भी हो सकता है उस रैक में ना हो so in that scenario there definitely there will be data transfer which will happen from in between racks also. But again, that there are 3 copies of the data, so probability there is one copy which is lying on the same block rack also. But again, that again depends on the different conditions. Yeah, definitely there could be a inter-rack transfer also for a chunk of the data, and that's the reason when I said you splittable files will non-splittable files will kill you, because let's say this is a file of 5 petabyte and that's divided into 5,000 blocks, and the file is not splittable, that will only be processed by one mapper. तो एक मैपर किसी एक नोड पे चलेगा एंड वो बाकी सारा डेटा 5 पेंटाबाइट का डेटा अलग अलग नोड से इस नोड पे ट्रांसफर होगा और वो मैपर उसे प्रोसेस करेगा. सो दैट विल किल योर सिस्टम because you can't in seek in between the file, and that's the reason you can't figure out what is the logical division of the data, and file is not splittable. Okay, so streaming we have not looked into. We will look into the streaming, then this will make sense. But here I wanted to show you how you can compress the data. Mm. So at different layers. So streaming will look at later on in our next classes. Okay. So then let's look at different file formats which are available for you. So we looked at different compression which you can apply on the Hadoop layer. Then let's look at the different file formats which are available for you and how those files, or basically how in which file format you should be storing over the data. And again, that will be useful for you at different scenarios. Sequence files. So you can basically, seek in between these files. You can sync to maintain the boundary of the block. You can you can achieve the compression at both the layers, that is block level and the record level. If you are lost somewhere while reading the data, then also you can pretty easily figure out the record boundaries in these files, and they basically work pretty good for as a container for your smaller files. So let's look at the file format, then that will make more sense to you. So this is how the file is basically stored. You have the header, and then the record records some sync pointers which helps you to sync in between if you missed your pointer. So similar to your uh, around 5-10 years back you used to use that those audio cassettes. So अगर next song play करना हो तो you just keep on doing forward play, and then song से थोड़ा सा आगे पहुंच जाते थे, फिर then rewind play, and then finally you reach the start of the song. But in the CD you just say next and you reach the next song. So these things pointer are similar to that. You can pretty easily figure out the record boundaries, or basically these are randomly placed or basically placed at a predefined frequencies. So but if you lost the pointer, you can pretty easily sync your pointer. So header basically contains your key and the value classes, the compression details, and compression codecs, and if user defines some metadata kind of thing. And the record looks something like this. So record contains a record length, key length, and the corresponding keys and the values. So if in a record there are 10 keys, so that will contain the length of the record, कितना record की length है, उसमें फिर keys की length कितनी है, and फिर सारी keys and फिर सारी values. So and then if the record is compressed, it will look something like this. It will contain the record length, keys, and the compressed values. Keys are not compressed. So if you do a record level compression, your data will be stored something like this. And if you do a block level compression, your data will be stored something like this. Number of records, compressed key length, compressed keys, compressed key value, compressed values. So this is how your data is basically stored in these files. You have the header of the file, and then the blocks, and in between they are sync pointers. And block can contain n number of records. And you can apply the record level and or block level compressions. So basically what you do is your records are smaller files, and that's the reason I said these files can basically help you in basically work as a container for smaller files. So let's say I have a lot of audio files which I want to keep up. So I can create a sequence file which will help as a container for me for n number of audio files, and I can use sequence file for those kind of things. And as these files are splittable by their virtue of how they store the data, so if you apply zip compression on these files, you apply the compression basically on the records or on the blocks, you can then also achieve the logical boundaries of your data, and you can basically a files are splittable. So with the help of zip also you can split your data. Make sense? Does this make sense?
Yes.
Okay, so let's try to create a sequence file for us, and then we'll try to read it, and I'll just show you what I'm talking. So, अरे यार वो चलेगा. Okay, let me start the VM box. It will take a minute time or so. Then I'll try to run this program for you. So what I'm going to do is so this is a program which will create a dummy sequence file for us. Which the sequence file will not contain anything great. It will just contain these files occurring one by one again and again. So 1, 2, buckle my shoe, 3, 4, shut the door, and so on. So again and again, this file will keep on appearing up 100 times. And this will be stored as sequence file. So we'll create this file. Then we'll try to read this file. So while reading, we'll also print this if there are any in between sync pointers. So wherever sync pointer is coming up, I will be appending that thing with the star. So वो star आएगा, position आएगी और data आएगा. And then what we'll do is we'll try to sync to this star, and we'll see whether we can read the data with how basically that syncing helps in between while reading the data. So we'll try to run these programs, and then I'll show you what is basically happening up. So it will take a minute or so to start. So again, this program, this all code is with you. You can try it, run anytime. And once you do your map reduce exercise, then we'll look at some other codes also. So you can see देखिए इतनी सारी चीजें स्टार्ट होती है इसमें Nox, Falcon. Uh, so Nox is basically used for security. Falcon is a framework on top of Uzi. Hive Server 2 is a server which manages the Hive services. So it's almost started. Let me just try to connect to this. So started up. Okay. So other processes start होते रहेंगे background में. CD. Oh, sorry. LS. Design Pathshala. LS CD. Uh, map reduce LS. Okay. तो वो जार ऑलरेडी बने के पड़ी हुई है जो मेविन से बनाई थी. We'll use the same जार. Okay. So what I'm doing is I'm just using the same jar. उसके अंदर ये class file का नाम दे दिया sequence file. Okay. First we'll write a sequence file. So sequence file writer, and we'll write it to this file. So I'll just delete this directory first. So so Hadoop fs minus rm minus r minus. अरे यार ये ऑफिस में मैं मैक पे काम करता हूँ. कंट्रोल सी और कंट्रोल वी. I'm just okay. So directory is not there. Cool. Okay. So let's try to run this thing. So we are creating a sequence file at this location. Okay, a sequence file is created. वो same rows 100 बार repeat हो रही है, and this is what we started writing up. ठीक है. Now let's look at this. Hadoop fs minus ls. क्या हो गया? Okay, so now Hadoop fs minus cat, and let's look at this file. So कुछ नहीं दिखेगा इस फाइल में because this is a sequence file. And that's the reason, if you remember, मैंने आपको बताया था there are sequence file input format, sequence file output formats at the mapper phase and the reducer phase input file formats में. So this is the sequence file which I was talking about, and there are particular readers for this file who can read this all this data for you. So, but there is a utility in Hadoop also. If you want to read this data, Hadoop fs minus text. So this will convert this file to text format and will display it to you. Okay. Now we'll try to read this from Java, and we'll try to put a star wherever your sync pointers are coming up, जो मैंने आपको PPT में दिखाए थे अभी. Okay. So this is a reader class. ये सब मैंने यहाँ पे हेल्प लिखी हुई है जो भी मैं बताता रहता हूँ. Hadoop file, how to read it, minus text करके. Everything is written over here for your help. So So this will print the position as well as so this is the position basically in the file byte offset जो मैं बोल रहा था. So these are this is the byte position in the file, and you can see here I can see a star. So there's a sync appearing over here, and here also I can see a star. So there's a sync appearing over here. So now let's read this data and that will make sense to you. So what I'll do is I'll just tell him कि कौन सी position से data read करना है. So let's give him a position. I want to read this thing. Now see it read the data for me. Now I say, so I'm giving a pointer somewhere in between the record. And can read because it is not able to find out the logical start of the boundary of a record. So in such a scenario, if you are lost in between, this is a sync which is basically helps us. So here what I'm doing in the code is I'm not doing anything great. I'm just saying it to sync. So यहाँ पे मैंने कहीं dot sync call कर रखा होगा reader dot sync. So if we are lost, we just call reader dot sync and it will sync me to the next sync pointer. So if I run this file and give any position in between, let's say मैं देता हूँ 4030 or 3779 and 3779 give us 3770, so it will read this data. It will sync to this pointer and will read this data. क्या हो गया main java, oh sorry, वो file का path. So what was the file name?
Miraj, can you hear me?
Yeah, I can hear you.
Okay.
So see, we read that data which is coming at that pointer 15. Yeah, go ahead.
ये ना मेरे को समझ नहीं आया ठीक से कि मतलब हम करना क्या चाहते हैं, गोल क्या है हमारा.
So goal ये है हमारा. I'm just trying to tell you different file formats which are again useful in the Hadoop world. So when you will be really storing your data, you will not always be storing in your text files. Based on your data, based on requirement, you will be using different file formats as along with the compression technology on the files, so that you store your data in a precise file format and the precise compression, so your jobs run at a much faster pace as you can think of. You can change the rate. Basically, you can achieve performance benefits up to 70 to 80% by just using precise file formats, precise compression, and precisely basically creating your job queues.
Okay.
So I am trying to give you the glimpse of different file formats and different compressions which are available in this world, Hadoop world, so that when you are really architecting a Hadoop cluster or basically working with on the Hadoop cluster, you can think of what is the best suitable file format for you. So with this program, what I'm saying you is what is the benefit of this file. So although you will not never be writing this Java code to read the file kind of thing, everything will be done internally for you. You have to just tell the MapReduce that file input format, sequence file cut file input format use करना है. It will read the file for you. But what is the benefit of using that file format? That you will only be able to understand if you understand this what the flow which I'm telling you, which are internally be used by a file input file format only. Sorry, sequence file input file format.
तो ये जो अपना सिंक पॉइंटर है जो तुमने स्टार लगाया इसका क्या वैल्यू है, मतलब
ये यहाँ पे देखोगे. तो मैं जो बता रहा था आपको एग्जांपल दे रहा था, एक मैंने एग्जांपल दिया था अभी इसका वीडियो का ऑडियो कैसेट्स का. तो अगर मैं बीच में से कहीं से पढ़ने की कोशिश कर रहा हूँ, I will not be able to read it. I have to sync it to a pointer. सो
ठीक
एक
है।
ब्लॉक में कई सारे रिकॉर्ड्स होंगे। सो अब मुझे लॉजिकल एंड पता करना है, तो
होंगे।
I will just quickly sync and I will start reading from there in the next uh, split. So they help you in very fast reading of the files, figuring out the logical start of your data.
Okay.
Make sense now?
Yeah, I'm thinking actually. I'm just trying to correlate that with an example. So suppose if I have got, say, this is only one block, right? So you have got in the block you got header and the record sync block, and then record sync, and then so एग्जाम्पल मोर प्रिसाइजली, जैसे तुमने जो एग्जाम्पल दिखाया था ना वहाँ पे, what the text file which you said, right? So if you can map that example to this block, then
So
it will
let's
be
say,
helpful to understand.
so let's say this is your let's say this is your block,
Okay,
and this is your one block,
ठीक है,
and this is your another block. कहीं आगे तक जा रहा है.
ठीक
So
है.
जब sync call होगा, it will start finding the logical end of this. So this data would be transferred to your another this mapper, and it will start reading from here. So pretty fast हो जाएगा. उसको फाइल को पढ़ के खोल के नहीं देखना पड़ेगा कहाँ पे स्लेशन आ रहा है. It can quickly go to the sync pointer and start reading from there. So फाइल splittable हो जाती है आपकी बहुत ही आसानी से if you lost in somewhere in between your pointer kind of thing.
तो हेडर बाहर रहेगा क्या?
हेडर ब्लॉक में शायद आता है यार, हर ब्लॉक में भी होता है हेडर की इंफॉर्मेशन.
The way you drew it, I thought हेडर बाहर होता है.
हेडर ब्लॉक के अंदर नहीं होता क्या? हाँ शायद ब्लॉक के अंदर हेडर नहीं होगा आपका. हेडर शायद एक ही बार आएगा. देखना पड़ेगा, मुझे भी आया है. आई एम नॉट 100% श्योर. आई थिंक प्रॉब्ली प्रॉब्ली हो सकता है एक ही बार हो वो फर्स्ट ब्लॉक से पढ़ के. नहीं यार, आई हैव टू चेक कैसे हेडर कैसे रहता है. आई एम नॉट 100% श्योर. हेडर शायद सब में हर ब्लॉक में कुछ होना चाहिए हेडर की इन्फॉर्मेशन, कुछ तो नहीं चाहिए. आई हैव टू चेक दैट थिंग. हेडर आई एम नॉट श्योर 100% श्योर.
ओके, नो प्रॉब्लम. तो जस्ट मैं समझने के लिए बोल सोच रहा हूँ, आई एम जस्ट स्पीकिंग लाउड सो दैट आई अंडरस्टैंड इट. ओके, सो लेट्स अज्यूम दैट हेडर इज, जहाँ पे भी हो, अंदर हो या बाहर हो, तो हमारे पास हो गया रिकॉर्ड सिंक, और फिर एक रिकॉर्ड स्प्लिट हो गया. ठीक है. आ, उसके बाद फिर से रिकॉर्ड आए, फिर डिड यू ड्रॉ अनदर
So this
सिंक
is
पॉइंट?
so this is your mapper one. This is your whole mapper two.
ओके, ये बीच का लाइन क्या है इसमें, रिकॉर्ड और सिंक के बीच में जो है मैपर
वो
टू
इत,
में?
वो इतना डेटा फिर ट्रांसफर होगा ना ये, क्योंकि दिस इज द लॉजिकल एंड ऑफ योर डेटा. यहाँ पे मैंने क्या किया, मैंने सिंक करा. मैं यहाँ से पढ़, मेरे यहाँ पे ब्लॉक खत्म हो गया था. मैंने क्या कहा, मैंने पहले रीड करते हैं इसको दोबारा से, एक सेकेंड. फाइल फॉर्मेट सीक्वेंस फाइल सीक रीड. ये हो गया. ओके. सो लेट्स से मेरा यहाँ पे 3650 पे खत्म हो गया मामला. 3650 पे खत्म हो गया. तो अगर मैं 3650 से पढ़ना चालू करूँ तो मैं लॉजिकली नहीं पढ़ सकता, क्योंकि फाइल फॉर्मेट इस तरह से स्टोर्ड है कि मैं प्रैक्टिकली नहीं पढ़ सकता. सो व्हाट आई ट्राई टू डू इज, एंड बट मैं सिंक पॉइंटर्स pretty इजीली फाइंड कर सकता हूँ फाइल में बेस्ड ऑन द डेटा जिस तरह से इंटरनली स्टोर करता है. आई डोंट केयर अबाउट दैट थिंग. सो व्हाट आई एम टेलिंग यू इज फिगरिंग आउट दी ऑडियो कैसेट में नेक्स्ट सॉन्ग पे जाना है मुझे. मेरा मेरा काम, मैं it makes only sense me to play a song from the start only. I can't just randomly play a song. and the CD I can just play next, press next and play the song. Same thing happening over here. मेरे को next thing पे जाने के लिए बहुत ही fastly I can go up, and that's helped me to split my files pretty easily.
अच्छा, तो ये जो ब्लॉक डायग्राम है ये सीडी को एनालॉजी में लेके बनाया गया है, करेक्ट?
एक सीडी क्या एनालॉजी में लेके बनाया गया है, बट ये जरूरी नहीं है कि आपका मतलब ये सॉन्ग नेक्स्ट सॉन्ग नेक्स्ट सॉन्ग नेक्स्ट सॉन्ग एक साथ 10 सॉन्ग भी प्रोसेस हो सकते हैं, बट जब आपका सॉन्ग स्टार्ट होगा कोई भी प्रोसेसिंग स्टार्ट होगी वो सॉन्ग के स्टार्ट से प्रोसेसिंग स्टार्ट होगी। ऐसा नहीं कि सॉन्ग के बिटवीन से प्रोसेसिंग स्टार्ट हो जाए, बिकॉज दैट विल नॉट मेक सेंस टू मी।
तो अगर हम ठीक है, अगर हम वो वाला let's say like each record is a song, suppose let's start it that way, okay?
हम्म। तो
ठीक है।
मैं हम्म तो मेरे को जब ब्लॉक, यार मेरे को सिंपल सी बात है, ये मेरा एक ब्लॉक है, ये मेरा दूसरा ब्लॉक। पेन का कलर चेंज करते हैं। ये मेरा एक ब्लॉक है,
हम्म,
ये मेरा दूसरा ब्लॉक है।
ठीक है।
अब मेरे को इस मैपर को डेटा को डेटा कंप्रेस्ड है और सॉन्ग की फॉर्मेट में है, इसको लॉजिकल एंड निकालने के लिए डेटा को पढ़ के प्रोसेस करना पड़ेगा, तभी पता लगता है डेटा लॉजिकल एंड हुआ नहीं हुआ। करेक्ट।
राइट।
अब इस हर टाइप के डेटा को लॉजिकल एंड निकालना इज अगेन अ टाइडियस टास्क फॉर यू। यू हैव टू रीड द डेटा एटलीस्ट, बट विद हेल्प ऑफ स्टिंग पॉइंटर, एक पॉइंटर है फाइल के अंदर जो कि एक पर्टिकुलर बिट होगी या बाइट होगी किसी पर्टिकुलर यूनिट तरीके की, आई कैन प्रिटी इजीली फिगर आउट कि मेरा लॉजिकल एंड कहाँ हो रहा है डेटा का। तो मैं कहूंगा इतना डेटा उस ब्लॉक में चल जाओ, क्योंकि ये डेटा मैं यहाँ से प्रोसेस करना चालू कर रहा हूँ, मैं यहाँ से प्रोसेस करना चालू कर रहा हूँ।
ओके।
मैं बिना डेटा पढ़े देना है कुछ करे, मैं एक मतलब विदाउट एनी डूइंग एनीथिंग आई एम एबल टू फिगर आउट द लॉजिकल एंड ऑफ द और लॉजिकल डिवीजन ऑफ द डेटा, एंड आई स्टार्ट प्रोसेसिंग फ्रॉम दिस ब्लॉक on this mapper.
ओके।
So yes, syncs basically help you to sync your pointer pretty fastly to a logical start of a record.
ओके, ठीक है, आई गॉट इट। एक काम करें क्या, मुझे 5 मिनट का टाइम चाहिए होगा। द गाय वाज एक्सपेक्टिंग इज रिंगिंग द डोरबेल, सो आई हैव टू गो एंड आंसर इट।
Sure, sure, sure.
सो
So we can take a 10 minutes break and then we'll again combine after 10 minutes. Okay.
ओके।
Okay.
Viraj?
Are we back?
I'm back. Not sure about Shekhar.
Oh, Shikhar also pinged his back. Okay, so pinged his back, probably his back only. Okay, so similar to sequence files, there are files called map files. So only the difference between sequence file and the map file is map file not only stores the data like a sequence file, but they also store a uh, basically lookup key value pair kind of thing, or index file parallel to the file, parallel to your data. So that is not 100% index, that is just a partial index for your data. So let's say your key, so this will contain, let's say 1, 6, 20 and 50, and the corresponding pointer in the file. So this is pointing to, let's say, position 0, this is pointing to 120, and this is pointing to 560, and so on. So when you're looking for any key, you can just see get that keys. So let's say you are looking for key 15. So you can easily start from 120 and can start seeking the file. So these are the partial index which are also stored with your data. So if I create a map file for you, so again the same file, I'm using the same data to create the map file. And but when we'll create this map file, you will see on not only the data, uh, there is a this thing index file also created with your data. So what we'll do is we'll just remove this, delete the output folder first. Hadoop fs minus rm minus r uh, and then what we'll do is we will, विंडोज 7 से घटिया ओएस आज तक कोई नहीं आएगा. Okay, so if I look over here, Hadoop fs minus ls, so we'll see there are two files lying over here. So if I look at this file, Hadoop fs minus text, so that contain only the partial indexes. And if I look at this data, that will be the whole data. Hadoop fs minus text. So this is the data stored in a sequence file only, but we have a data file. Oh, sorry, the partial index file, which helps your quicker lookups in the file. So that's what your map file is. Any questions? Okay, I assume no questions. Okay, RC files. Interesting thing.
Can you hear me?
I can hear you.
Okay, yeah. So I was just trying to absorb a little bit of this concept. It seems to be a new concept to me. So I'll try to get it more. If I have more questions, I'll let you know next class. But I definitely will have some.
Sure, sure, sure. So RC files. Okay, so till now in the Oracle world or whatsoever you are in your basically the way you store the data. So basically what you do is you store column 1, column 2, column 3, column 4 for row 1, then for row 2, column 1, column 2, column 3, column 4, and so on. This is how you store the data basically, है ना? यूं जाएंगे and then फिर यूं जाएंगे. Now let's say when basically when I store the data into your file system, and majority of my queries on the data is something like this: select employee ID comma employee salary, where employee department is equals to IT. This is how my normally queries are. So I normally do not read all the columns for each row. I have for each and every kind of query on the data, I am always interested in few of the columns, maybe it column 1 and column 3 or something like this. So storing data like this has a lot of problems while I'm reading this, because I have to read the whole row by row, because this is how it's stored internally. So अगर वो basically memory में देखूंगा तो ये कुछ ऐसे stored है. ये column 1, column 2, column 3 ऐसे stored है कुछ C1, C2, C3, C4. Then for your row 2 row 2 start हो गई, उसका C1, C2 and so on. So there's a lot of issues while reading this data. So what we do in RC file format is, rather than storing this data something like this, we store it something like this: R1 C1, R2 C1, R3 C1, then R1 C2, R2 C2, and so on. So rather than storing it something like this, we store it something like this: ऐसे, फिर ऐसे, and फिर ऐसे. So that is row columnar format. So this is the one advantage which I told you. If I am reading the columns, I can read them pretty fast, because I have to just read the columns on a go. So if I was considering column C1 and column C3, I have to just read them sequentially and do not do any kind of read seek basically process kind of thing. This is the one advantage of RC file. Can you think of some other advantages of RC file?
Access would be faster, I think,
Sorry?
because the access would be could be faster because the column value is stored with the data.
Column value stored with the data.
So if you want to go to C2 in R2 of R2,
Yeah.
then you can directly go to that cell, which will be R2 C2, instead of finding out where R2 starts
How the
and then
TK
go to
basically,
C2.
yeah, that is what I'm saying. Yeah, the seeking would be faster. Anything other than that?
Mm.
You can achieve pretty good compression on your data, because the same columns will have similar kind of data. And how you do the compression of the data is, you just find out similarity in the bits and bytes. On based on that, you do the compression. And the compression technologies work on that. So if the same kind of data is stored together, you can achieve high compression on your data.
That's true.
Okay. So let's say this is my data. So what we do is, we not only do the vertical partition of the data, we also do the horizontal partition of the data and the vertical partitioning. So we divide the data into blocks. So let's say एक block में 100 rows आएंगी. So 100 rows will be considered a single block, and then those rows will be divided something like this. And फिर यहाँ पे आएगा, फिर ये ऐसे आएगा, ऐसे store होगा. And similarly for this thing. So it will be something like this. Okay. These are row groups, and this is how it will be stored up. It divided into different row groups. It divided into row groups, and this your data is basically stored up. एक साथ एक column, दूसरी बार दूसरा column, तीसरा तीसरा column, चौथा बार चौथा. So these are groups of your data. So I told you
No, no, go slow on the next table. I need
this
to see the final output,
this is your data.
right? So,
This is your this is how you divide it horizontally, and then you divide it vertically, and this is how finally data is stored.
row group 1, so your green one is your first row group, right?
Yeah, this is my
And
first row group.
ठीक है, इसमें रो ग्रुप 11, 21 and 31 है.
11, 21 and 31. 12,
हाँ, एक
22,
मिनट.
30. ठीक है.
C2. ओके, तो ये तो सिर्फ रो आईडी हो गया ना, जो हमारा
रो
R1
आईडी नहीं, ये
R2 था,
डेटा है.
राइट?
This is a data. So this is a table. This is a data. 11, 21. This is a data which I am showing in the example. So this is a practically
ओके,
data is stored. Practically data is stored होगा.
ओके, ठीक है.
To make it more मतलब 10 to make you understand, that's the reason I given you the मतलब data structure का you can easily segregate the data. Okay, so that is I already told you we do a vertical and horizontal partition of the data, and okay, this I've already discussed up. So I already discussed you about the compression. Okay, so we'll talk about this thing. So if this is my data, I'll be practically storing it like this. And if I have to search for something, it's pretty easy for me to find out the things because my similar columns are stored. Basically, the columns are stored together. So RC file formats are highly used when you are using Hive. So Hive is a query tool interface on your SDFS file system. So basically, you expose your data lying into a file system as a table, and when exposing your data lying into the file system as a table, RC file formats will basically fasten up your searches or queries running with the help of Hive because you are particularly looking at a particular column. Most of the time you are looking at some of the columns only of the about of 100 or 50, 15 columns in your file. So RC files are highly used when you are working with Hive.
ओके,
Then ORC, so optimized row columnar format. This is more optimized as compared to your RC. So what is optimization? So you can read this thing. I'll talk about all these things. So basically what happens up is you not only divide your data vertically and store them in a columnar format, you also store some other information with the data, like index of the data and the footer of the data. So but what the index of the data contains is, index of the data contains things like what are the min and max values of different columns in this file, and so basically let's say I run a query, select from employees where salary is uh, greater than 5 million, less than 10 millions. So what I'll do is I'll just quickly read the index of the data and just see if there's any record which has such a salary range, because I am storing the indexes of each and every column. If there's nothing, I'll easily skip the whole block. So if nothing, I'll skip this block. If nothing, I'll skip this block. If there's something in this block, I'll start reading this block, and we'll just take out the data. So ORC files are much faster as compared to RC files.
ओके. सो ये जो इंडेक्स कॉलम है, दैट इज व्हेन इंडेक्स
कुछ
डेटा
नहीं.
इज स्प्लिट इनटू.
So you don't have to worry about all these things. वो सब कुछ अपने आप बना देता है. मतलब the process which is writing the file, but this is how the data is stored. So then it makes sense to you. मतलब I'm trying to make you understand why the ORC file is better than RC file.
Okay, I was just trying to understand that there is a index data, row data, strip footer.
So data is your real
ये
data.
सब
This is your real data. This is your index about the data, and footer में information कुछ ऐसी आती है. So footer contains a list of number of rows, some aggregates, count, min, max, and your header contains uh, your index.
So it's basically mainly the metadata information about the data.
Yeah.
That is
So basically,
rows per strip each.
these two things are basically a metadata about your data. So they store the index की min क्या है, max क्या है, counts क्या है, all those things.
Hmm.
And that's how your searches become much faster. Where it's stored does not matter to us because we are not basically interacting at the file level interface. But if we choose the correct file format to store the data, we have to just give the file format as XYZ, whatsoever file format we want to use. We can achieve pretty good reads, writes kind of thing on our cluster.
Hmm.
Avro files. So when this dog cutting was basically creating a Hadoop, basically working on the Hadoop thing, the major challenge which they faced was is they were writing everything in Java, and other teams which were processing the things were might be using different technologies. So that was a major problem which they're facing was your serialized data which Java was creating up that was not that cannot be processed in any other language because serialization can again be read by the Java only. So they created a file format, something called Avro file format. These file formats you will be using up if you are interacting with n number of team across your company or organization or outside the organization, and if you have to do a lot of data transfer between your teams. So in such a scenario, people use Avro files. The beauty about these files is they although they are not only splittable, they are not only do not only support compressions, splittable kind of thing. They not only contain the metadata of the data, but they are technology independent also. So basically, a file written with the help of Java can be read with the help of C++. So they are platform independent as well as technology independent. So uh, so basically, they can be processed with any of these technologies. So these file formats are highly used if you have to transfer your data across different teams or across different people. And another beauty about these files is they also contain the metadata of the data. So somewhat similar to your JSON. So the beauty is, let's say I have 4 fields in my file today, and I started writing those things. And tomorrow my version change, and now I have, let's say, 5 fields. But if I'm reading some older file which have only 4 fields, so as the file also contain metadata about the file, your reader which is reading the file and it is the latest reader, that will not fail up because that reads the metadata from the file only, and if something is changed in the data, that will just easily skip that thing and it will just read the data which is required or intended for it, similar to your JSONs. So JSON में key and value pair kind of thing होती है, वैसे यहाँ पे metadata stored होता है फाइल के साथ. So all these things would be sounding to you pretty strange कि मैं क्या बात कर रहा हूँ, क्या मतलब why I'm talking all these things. But if you remember these points, these will be pretty helpful for you when you are really working on your whole cluster. Practically you will not be interacting with any of these files. आप केवल फाइल फॉर्मेट दोगे रीडर में या राइटर में कि ये फाइल फॉर्मेट मुझे यूज करना है रीड करने के लिए, फाइल फॉर्मेट मुझे राइट करने के लिए यूज करना है, और दिस फाइल फॉर्मेट इन विच आई वांट टू स्टोर द डेटा. Internally क्या हो रहा है, you will never be looking at this. You will be just doing Hadoop FS minus ls kind of thing. But if you understand internally file कैसे store हुई है, क्या उसके benefits हैं, then it will be pretty easy for you to choose which file format or which compression you want to use. So that's the reason I'm talking all these things. प्रैक्टिकली आप कभी भी खुद से कोई फाइल नहीं बनाओगे, खुद से कुछ अंदर फाइल को खोल के नहीं देखोगे क्या उसका वो है, ऑल दोस थिंग्स यू विल नेवर बी लुकिंग अप.
Okay.
So and so the example which I'm giving you is the real example which you face up, जब हम challenges daily face करते हैं वही example मैं normally दे रहा हूँ. So अगर आपने फाइल का स्कीमा बहुत ज़्यादा चेंज होता है, this is a pretty common scenario. So when you're transferring your data between different teams or different organizations, it's pretty normal you are changing the data, or basically changing the structure of the files kind of thing, or changing the columns in the file. So as these files contain the metadata about themselves, it's pretty easy if you have written that thing in using. So this is what I'm talking about. So if you have written it with 3 columns or 4 columns, you can read it with the reader of 3 columns only without failing or without technically giving any compilation errors, because the metadata is stored with the file. So these are the different these are different primitive data types which they support. So it's all normal. What are the different data types which are supported by that? It's not only support these primitive data types, these file formats, the Avro. It's also support the complex data types like array, map, record, union, kind of thing. So basically, this will help you if you have to create a file specifically giving different. मतलब आपको अपने Java का object इस file format में convert करना है, that time you will be using these different types. So one of the file format which I have not covered in this PPT is the Parquet file format. You can see it over here. So Parquet and ORC are, I would say, uh, what are the correct word I should use is, are interchangeably used in the Hive world. Uh, Parquet and ORC are both RC file formats. Parquet and ORC, that's the reason they are highly used in this industry for storing your data, because most of the time you are storing your data and reading the data column wise only. So Parquet and ORC both are RC file formats with optimizations internally embedded in these file formats. So दोनों का read time, write times almost similar आते हैं if you look at the comparison about these two files. So these are interchangeably used in the Hive world by people across the industry.
So a small question there is that if the file is getting smaller, right? Is the because the compression is higher on text to ORC file, processing speed will increase, correct?
IOs will increase. IO time would decrease basically. Processing.
Yeah, IO time will decrease.
Yeah.
But speed of processing the data.
Decompression करने में मुझे उसको CPU ज़्यादा लगाना पड़ेगा. There will be time which will be required to decompress the data. So that will add up my processing time.
Okay.
But I'll get a
think
benefit.
about that example.
But I get a benefit in IO, which is a major bottleneck in any of the hardware.
Okay. So think about it, right? If हमारा 100 GB का block है, suppose with the example which you showed, right? तो हमारा एक block 100 GB का 585 के लिए हमें 6 block लगेंगे original file में, ठीक है? Correct?
Okay.
Now अगर मैं ORC पे जाता हूँ तो मुझे 2 ब्लॉक लगेंगे क्योंकि 131 GB का फाइल साइज हो गया हमारा।
हम्म
100 पे एक रहेगा, 31 पे दूसरा रहेगा।
वो ये
Now,
in this example by default ORC uses ZZip compression. You can again change that thing. So it's with ZZip ही Parquet के अंदर by default मेरे को नहीं पता कौन सा होता है. So based on that this example is there or this picture is there.
हाँ मतलब जो भी एल्गोरिथम हो उससे हमें मतलब नहीं है, मतलब
हम्म
बेसिकली मैं ये देखना चाहता हूँ कि जो भी एल्गोरिथम यूज हुआ, बट हमें अगर ओआरसी फाइल है
हम्म
सिंपल टेक्स्ट फाइल की जगह पे तो हमें 2 ब्लॉक लगेंगे।
हम्म
ठीक है, अब मैं इसको प्रैक्टिकली समझने की कोशिश कर रहा हूँ कि अ, जब मेरा डेटा इसमें राइट हो रहा है
हम्म
131 GB डेटा 2 ब्लॉक में,
हम्म
तो वो फास्टर राइट होगा बिकॉज IO would be much faster for 131 versus 585, right?
Yeah, of course.
Right. Now, then when the reader comes, it will read, instead of reading 6 blocks, now the reader was only reading 2 blocks, right?
Yes.
Now, but the reader will take now higher time to read the data because it just doesn't have to go and make sense out of the data. It has to also intermediate step uncompress the data to read it.
Yes.
Then when it so basically वो फैक्टर पता है क्या कि कितना होता है हमारा जो अगर हमारा सपोज करो ORC फाइल में 78% स्मॉलर हो जाता है, do we know if it is 50% more read time or 30% more read time?
30% more read time.
I'm just showing a number, but do we know what is the number
Yeah,
by
that
which it
depends
gets
again
the
on the
read time?
cluster. That totally depends on the cluster. Let's see देखो अभी कुछ कुछ चल रहा है मेरे क्लस्टर पे. Attendees, Viraj, make presenter. Yes, show my screen. So you can see my screen, right?
Yep.
ठीक है. So देखो अभी बहुत सारा प्रोसेस चल रहा है मेरे क्लस्टर में. ठीक है. So अब देखो जैसे अभी मेरे क्लस्टर में टोटल रैम है, इस वाले क्लस्टर के अंदर रैम है टोटल 822 GB, आउट ऑफ विच आई कैन क्रिएट 205 containers are running and still there is a memory. There is no memory right now left. Oh, there is still 44 GB which is left, which can accommodate few more containers. So each container will run your mapper reducer. Now, uh, so see, it ran 105 mappers. ये खत्म हो गया chemical, नहीं हुए. So अब क्या हुआ कि ये different mappers ने this is where you can look at कि कौन से मैपर ने कितना टाइम लगाया, कौन से मैपर ने कितने देर में खत्म हो गया and all those things. So practically there is no as such correct conversion criteria kind of thing to for your question is what I'm saying is first you will run it with the text file. फिर आप देखते हो थोड़े दिन में आपका मैनेजर आता है, नहीं यार ये तो बहुत टाइम ले रहा है कुछ करो. अच्छा फिर यार मिराज ने बताया था ओआरसी फाइल अच्छी होती है, फास्टर होती है, इस डेटा को ओआरसी में रख देता हूँ और मेरे मैपर भी अब कम बन जाएंगे एंड थोड़ा फास्ट भी चल जाएगा. आपने ओआरसी में रख दिया, देन यू विल सी कि इसने इतना टाइम लगाया, इस मैपर में इतना टाइम लगाया, दोस काइंड ऑफ थिंग. देन यू विल सी कि नहीं अभी भी मेरे को मेरी मेरी रिक्वायरमेंट 2 मिनट से कम में हो जाए सब कुछ, लेकिन ये अभी भी 2.5 मिनट ले रहा है. Then you will see chalo, I'll see with Parquet file and the compression rather than gzip, or I'll use lzo kind of thing. So this is a different thing which you have to try up to figure out on your cluster. Second thing what you have to look at is right now you can see in my cluster. So अगर यहाँ पे देखते हैं अगर हम, so मेरा क्लस्टर अभी जो है अगर मैं देखूँ तो रैम बाउंड चल रहा है. अगर मैं सीपीयू के स्टेट देखूँ मेरे क्लस्टर पे, so let's open Ganglia. So CPU stats कितने हैं क्लस्टर के? CPU ग्राफ दिख रहा कहीं? मेमोरी नेटवर्क। सो देखो, एक पॉइंट पे मेरा नेटवर्क ट्रांसफर काफी बढ़ गए थे। सो आई हैव टू लुक एट दोज जॉब्स जो नेटवर्क में ट्रांसफर कर रहे हैं। मुझे उन फाइल्स के अंदर कुछ कंप्रेशन करना पड़ेगा कि एक नोड पे पहुंच जाए, कुछ करना पड़ जाए। So I have to look at the job and the corresponding graphs to figure out or physically optimize the things. So that is what I'm saying कि वो आप at the first go you can't think of कि मेरे को यही compression use करना, मेरे को यही file format use करनी है। That you have to figure out based on the jobs which are running up. So there are some jobs which run up daily. There are some jobs which you want to do real time kind of thing. So based on the different parameters, different things in the cluster, you will be figuring out कि मेरे को क्या चीज use करनी है. And that's the reason I am trying to tell you or trying to make you digest the internals of these things so that you can easily figure out कि अच्छा यहाँ पे नेटवर्क बाउंड बहुत ज्यादा हो गया तो मैं कौन सा फाइल फॉर्मेट चेंज कर सकता हूँ, कौन सा कंप्रेशन चेंज कर सकता हूँ। सिमिलरली अगर मेरी एप्लीकेशन सीपीयू बाउंड जा रही है तो मेरे को कंप्रेशन इतना हाई नहीं करना चाहिए, मुझे एलजेड या स्नैपी टाइप का यूज कर लेना चाहिए। तो सीपीयू ग्राफ किधर आ रहा है? सीपीयू ग्राफ यहाँ पे कहीं आ रहा होगा, कहीं दिखता है सीपीयू ग्राफ भी आता है। ये रहा सीपीयू यूजेस। तो मेरा सीपीयू यूजेस फिर भी 80% के राउंड चल रहा है। तो मैं सीपीयू बाउंड नहीं चल रहा, मैं रैम बाउंड चल रहा हूँ अभी क्लस्टर के अंदर। मैं यहाँ मैं रैम बाउंड चल रहा हूँ क्लस्टर के अंदर अभी जो जॉब्स चल रहा है उनके लिए। नेटवर्क नेटवर्क में डेटा ट्रांसफर कितना हो रहा है? नेटवर्क यूजेस मेरा इतना नहीं है। नेटवर्क यूजेस लास्ट 30-40 मिनट्स में अभी बहुत ही कम है। सो बेस्ड ऑन दीज थिंग्स आई हैव टू प्रिसाइजली थिंक ऑफ कि मुझे क्या करना है, क्या करना चाहता हूँ मैं, which is the correct thing which I have to use up. So those things you will, वो अभी नहीं समझ, वही मैं कह रहा हूँ, इनको समझ लो, अपने दिमाग पे रख लो। You will really recall them when you are working with a cluster. तो तब याद आएगा, अच्छा हाँ
Okay.
यार ये चीज यहाँ पे हो रही है, तो शायद ये वाली फाइल फॉर्मेट मुझे मैटर करेगी, शायद वो वाला रीजन से मुझे मैटर करेगा। Then again, the project which I'll give you, there also you will think a little bit, but as such practically I can't explain you कि मतलब क्या हो सकता है, because that will again depend on different criteria, आप क्या यूज कर रहे हो। अब जैसे ही मैं यहाँ पे
Okay.
देख रहा हूँ, मैं यहाँ पे देख रहा हूँ, यहाँ पे नेटवर्क यूज बहुत ज्यादा हो गया, तो यहाँ पे नेटवर्क में ट्रांसफर हुआ है कुछ ना कुछ। तो इस टाइम पे मैं जॉब देखूंगा, मैं आई कैन फिगर आउट कि ये जॉब था, इसमें डेटा इस टाइप से है, ये मैंने क्वेरी चलाई थी, तो अब इसके अंदर क्या करा जाए कि मेरा नेटवर्क यूजेस कम हो। सो एट अ टाइम देयर आर लॉट ऑफ जॉब्स व्हिच कीप ऑन रनिंग। क्लस्टर है आपका, क्लस्टर पे 85 और यूजर्स होंगे आपके, प्लस 85 टेबल चल रहे होंगे, 85 प्रोसेस चल रहे होंगे जो आपका डेली डेटा प्रोसेस करेंगे। So these are the end of the day jobs which are running up, or basically in between day jobs which are running up and which are eating my cluster. So फिर I'll look at, so किसी की जैसे ये वाला जो था, किसी ने खोलूं, ये बहुत देर चल रहा है, इसने कुछ ना कुछ भर। सो सी, इसने 14,000 मैपर्स बना रखे हैं, 14,900 मैपर्स। इसके अंदर 101% इस फाइल फॉर्मेट में कुछ गड़बड़ है जो मेरे इतने मैपर खा रही है। तब मैं इसको देखूंगा और कल जाके मेरे को किसी को पकड़ना पड़ेगा, इसको सही कर देगा। इस फाइल फॉर्मेट को चेंज करना पड़ेगा, स्टेबल की को। तो व्हाट आई विल डू इज, मैंने देखी भी नहीं थी, आई एम टॉकिंग टू, आई हैव जस्ट फिगर्ड इट आउट। सो इफ यू लुक ओवर हियर, लेट मी ओपन इट। 100% इस फाइल फॉर्मेट में कुछ गड़बड़ होगी कि इतने ज्यादा मैपर बन रहे हैं, या क्वेरी में कुछ गड़बड़ होगी। सो यू कैन सी 2016, 15, 1510, 1510, 1510। अच्छा, बहुत सारी फाइल्स पड़ी हुई हैं सेम फोल्डर के अंदर, बहुत सारी फाइल्स पड़ी हुई हैं। सो ईच फाइल के लिए वो एक मैपर बना रहा है। So I can combine those files into a single file. Although I'm using ZZip, but I can combine those things into a single file and can create a BZZip, and that will reduce my number of mappers. So, so there is a table which is a problemless data. So I can get it corrected and I can reduce the number of mappers. If I reduce the number of mappers, my application, which is right now yarn bound, can be basically less yarn memory will be used up when this job will run up, but that will spool less mappers. समझ में आया मैं क्या बोल गया? आ रहा है
बेसिकली नटशेल में हमें ये देखना है कि भाई तुम्हारा जो डैशबोर्ड ग्राफ है ऑन नेटवर्क आईओ memory, CPU usage कहाँ पे है, so that you can do the right optimization.
Yeah, so based on that you will be able to figure out. And this particular example which I just now figured out, I can see now मैं log में जाके देख सकता हूँ कि फाइल फॉर्मेट में गड़बड़ है. फाइल फॉर्मेट भी सही है, ये बेसिकली एक ही डेट के लिए बहुत सारी फाइल्स बन रही हैं. सो ये बहुत सारी फाइल्स बन रही है तो हर फाइल पे एक मैपर बनेगा क्योंकि दैट इज द एंड ऑफ द फाइल. सो इसमें 14,000 मैपर्स बन रहे हैं and that is creating the
और ये जो
problem.
dashboard है,
This is
the
Ambari.
dashboard which you are showing,
Ambari, I'll
is
take
this
this is a Ambari dashboard. I'll take 15-20 minutes to explain to this dashboard. After I explain you what is yarn, that is Hadoop TutorText. So Hadoop TutorText समझ लोगे तो
okay?
उसके बाद में dashboard समझ में आएगा. So
ठीक है.
I'll explain this to you.
Has Prabhajit left the meeting?
I don't know. I've not
No,
heard.
no, I'm here only.
Okay, okay. Because I was seeing yes.
I'm just trying to digest all these things.
Okay, no problem. Yeah.
So
So yeah, go ahead. Couple of things I wanted to ask you for a favor, Miraj, before we end this call today. One thing is date-wise, if you can send me a table and say that, okay, class 1 is this PPT name, and then send it to me because we didn't get all the PPTs.
PPTs are there. Shekhar, if you go to the Google Drive, there is a shared PPT folder. So as soon as the class is completed or logical end of the PPT happens, I publish the PPT over there. So you can see there will be two PPTs over there in the PPT folder. This is the third PPT which I'll place it over there today.
ठीक है. ठीक है. ये कौन से Google Drive में? Because ना in Google Drive what I've seen is
there are four folders which I've shared with you. Google Drive की 4 emails आई हुई आपके पास.
ठीक है, मैं देख लूंगा अगर होगी उसमें तो.
ठीक है, वो 4 ईमेल्स आई हैं आपके पास. एक पीपीटी फोल्डर की ईमेल होगी. उसके अंदर 2 पीपीटीज बढ़ेंगे. थर्ड वाली आज मैं डाल दूंगा.
Okay. Why don't you put a class ahead also so that we can just go over and see
The class
आगे
ahead
क्या
I
होने वाला
do
है.
not do is I keep on asking the question in between so that you can do some brainstorming. So if I put the
Oh,
PPT in the
अच्छा.
next PPT, the answer is there. So वो
Okay, okay.
लोग बाग just keep on flipping up and फिर दिमाग नहीं लगाते लोग बाग.
Okay, okay, I got it. No, if you have a purpose, then it's fine.
Otherwise, I can share all the PPTs at the one go. I've shared everything else, so why can't put the PPTs also?
Yeah, I was also thinking about it. ठीक है.
Okay. Anything else? So अब next topic start करने का तो time है भी नहीं वैसे भी 10:45 yeah. So we'll start it. अच्छा, when do you want the next class? हमारी इस बार Saturday को भी नहीं हो पाई थी.
I can do Thursday night if that is okay with you guys.
Thursday night नहीं. अरे यार, okay. I am
Your Friday
traveling.
morning.
No, I am traveling this week. No. Let's have it on normal time only. Saturday only.
Saturday
Let's.
morning.
Yeah, my 8:30. Yeah, your morning. Yeah. जो हमारा schedule
Okay,
time है.
ठीक है. तो so we will have next class on Saturday and Sunday morning, correct?
Yup. Saturday morning, Sunday morning. Both of this. Yeah.
Okay. और अगर ना एक और चीज मैं सोच रहा था कि अगर if you guys have if you're struggling with time on Saturday evening and Sunday evening, we can do 1 weeknight and 1 weekend. Like we could do Thursday and Monday night if it is possible, or Friday morning and Tuesday morning your time?
I am fine because we have only two people. Normally मेरे पास 5-6 people होते हैं, तो उस case में we are stuck to the schedule only, which is prescribed.
Uh,
But with just 3 people, so if all the three are available, I am fine with that. But this week I am traveling from tomorrow to Friday morning, so probably not this week, but next week we can have it.
ठीक है.
Sure.
क्योंकि then what I see there is an advantage. One is basically Monday and Thursday there is a time gap between each class for us to get a hands-on. Second is we can keep our weekend free on a lot of personal things, especially we have to get into.
Sure. So next week you can have it.
देखते हैं करके एक वीक. हाँ.
हाँ ठीक है. But this week
Next week
मैं
करके.
available नहीं हूँ, तो not possible.
Friday evening कर सकते हैं. Friday evening
यार
in IST.
ट्रैवल करूंगा, मैं कंफर्म नहीं करूंगा मैं उस दिन ही करूंगा या नहीं करूंगा. So that's the reason if I'm or I'll drop you an email
ठीक है.
24 hours ahead. If you say both of you say yes, we can have it.
ठीक है.
Fine.
Otherwise we'll have it on schedule time.
ठीक है.
ठीक है.
Okay, so it's going good. कैसा चल रहा है? You're getting the things, learning up.
मेरे को तो काफी मजा आ रहा है. और I'm thinking that I'm getting it, but जब तक पूरा नहीं समझ जाओ ना, समझ नहीं आता कि तुमने कितना समझा.
और जब तक ट्राई नहीं करोगे, प्रैक्टिकल्स नहीं करोगे, थोड़ा सा ऐसा लगेगा. Try to do the MapReduce practical. Try to run the MapReduce code.
Right. तो वो एक बार environment setup हो जाए ना, लेकिन जो हो गया मेरा expression तो हो गया है. तो once we start doing it practically, then I think I'll get more hand of it. But I think I'm enjoying it so far, and it's going good. So let's see how.
Sure. Okay. Then see you next Tuesday.
Okay.
And by that time, try to run that MapReduce and all your problems should be resolved up. Form मैंने कर दी थी. If you still face any issues, drop me an email.
Sure. Pravijit, can I ask you for a favor?
Yeah, sure.
Okay. Did you send me your mobile number just in case I have I have to talk to you for anything?
Sure, I will send you.
Okay, thanks. And I did send you my number on some mail signature. So if I have to talk to you, then
Okay, sure.
I'll call
And
you.
even
Alright.
like for class also, like I'll send you my US number also. You can use that number for WhatsApp. If in case you need to communicate something
ठीक
for
है.
class time.
कोई भी एक तरीका हो जिसके साथ में तुम्हें even if the direct mobile number or WhatsApp number, whatever, I'm fine with both.
वही है, जो मेरा इंडिया मोबाइल है उस पे WhatsApp नहीं चलता, US नंबर पे ही WhatsApp है. तो I'll send you both my number, but you can't, you won't be able to call me on my US number. ठीक है?
That's fine. I'll directly call you on your mobile number. I feel more comfortable calling.
Yeah, same here.
Alright. और तुम्हारा odd event का कैसे चल रहा है दिल्ली?
बुरा हाल है, कल मुझे स्कूटी पे जाना पड़ेगा ऑफिस.
Yeah, I've seen some pictures. Friends posted pictures of Delhi metro and rush at the. But traffic कुछ control हुआ है?
ट्रैफिक तो बहुत कम हो गया, मतलब हाफ हो गया ऑलमोस्ट.
Okay.
Yeah, बट ठीक है.
मेरे
पास इवन नंबर कार है, ऑड नंबर भी है, बट ऑड नंबर जनरली घर पे भाई यूज करता है, सो इसलिए लाइक आई जस्ट वांट टू स्टिक विद माय कार. एंड टुमारो आई हैव टू either I'll take metro or I have a like spare two-wheeler right now for 15 days, so I can use that.
Yeah. I think India में थोड़ा car sharing का इतना ये नहीं है. People generally want to go by their own car.
Yeah.
यहाँ पे carpooling का काफी
नहीं, कारपूल का है दोनों जगह है, मतलब इंडिया में बहुत है. मैं गुड़गांव जाता था तो हमारी कैब थी, तो वो कार पूल ही था।
नहीं, आजकल
बट
ब्लाबला
अभी
भी
मेरा
काफी ज्यादा
ऑफिस,
वाइडली यूज हो रही है। मैं जयपुर से इस बार आया था तो ब्लाबला यूज कर रहा
हाँ काफ़ी है, एप्लीकेशंस भी हैं। मेरे दोस्त ने व्हाट्सएप ग्रुप खुद ही बनाया, उसमें 250 लोग हैं। सो वो रोहतक
ओह
से कारपूल
that's good.
करता था, काफ़ी लोग हैं यहाँ पे। बट दिल्ली छोटा बहुत है ना, स्पेस वाइज एंड नंबर ऑफ बिजनेसेस एंड पीपल बहुत ज़्यादा बड़ा है, बहुत लार्ज
Hmm.
बिजनेस है, तो उसकी वजह से क्राउड।
That's true.
यूएस में क्या है, खुला खुला है सारा, मतलब न्यूयॉर्क सिटी थोड़ा है। बट अगर
Hmm.
वैसे देखो सबर्ब में सिकॉकस या बाकी जितनी भी है ना प्लेसेस हैं, वो बहुत खुली है। तो एक बंदा एक गाड़ी से जाता है, और टोल बहुत ज्यादा है। अभी लिंकन टनल रोज पार करना होगा, $13 कौन देगा? सो मे बी
Hmm.
दैट्स ऑल्सो वन ऑफ द रीजन। पब्लिक ट्रांसपोर्ट इज गुड,
है।
यू
पब्लिक
डोंट
Hmm.
नीड टू वरी अबाउट पार्किंग एंड ऑल, राइट?
Hmm.
वो अच्छा है।
बट हाँ, ट्रैफिक
न्यूयॉर्क
यहाँ
में
पे
तो फिर इम्पॉसिबल है,
हाँ
जो मतलब अपनी गाड़ी से जाना है।
सही में, मैं खुद
तो,
वीकेंड पे जाता था तो मतलब वो फ्री ढूंढना बहुत टाइम लग जाता था, फिर
हम्म,
$10 $22 दे के पार्क करो।
हम्म,
बड़ा पंगा था। ठीक है।
alright. Alright, then talk to you guys on Saturday morning, your Saturday evening.
ठीक है, something you can have a look and later on the chat window.
Do you send some? Okay, let me just check.
So you can check it and just so, देख लेना.
Okay.
Okay then
Yeah,
guys.
yeah. Okay.
Sure. Thanks for your
I'll get
time.
you an email, Miraj.
ठीक है. Okay, मेरा खाने का
Okay,
ऑर्डर
thanks.
भी आ गया. चलो बाय बाय.
I see you.
ओके भाई।